Scion has been involved in the development of biopolymer and green chemical technologies for the past 10 years. Biopolymers, or bioplastics, are materials with similar properties to regular plastics, but with oil bases derived from green biological residues.
Scion has a number of activities in bioplastics. Firstly, it has some that are actually making the polymers that go to make the bioplastics themselves. So we are taking New Zealand residues, New Zealand waste streams, and converting them into polymers through either microbial or chemical technologies and making the plastics themselves. Scion identified at an early stage that there was a huge opportunity for renewable biomaterials, and it fitted really nicely with that industrial forestry processing capability that we have already developed. Today's bioplastics are really a very small part of the market. They're less than 1% of the whole plastics market. So they have some limitations today. For example, they're not as heat resistant, they're not as flame retardant, they're not as good as barrier properties in packaging, and we're addressing all those issues with our research, and all from a New Zealand resource point of view. A huge opportunity. It's forecast to be at least 20 or 30% of that industry in about 2020. So a lot of development required over the next 10 years at least. At the moment, all plastics coming into New Zealand are imported. Some of the ingredients can be made locally, and we're already doing that. I mean, it might be as simple as taking some wood fibre residues or some horticultural processing residues, things that are already around that we can transform and treat and turn them into extenders or fillers for plastics. Longer term, though, we would anticipate we'll be making our own plastics from our own resources and reducing more and more the imports and reliance upon those imports. We're working with a cross-section of industries, both in New Zealand and abroad. I mean, that includes, for example, industries that take up plastics in the furniture industry, and also in the cosmetic packaging, food packaging, nutraceutical packaging, almost any packaging really, which is really environmentally driven in the longer term future, we're partnering with. What about, would that be about 30 or 40 or 50% biomass content?
A little bit lower biomass content for this.
I mean, we've been doing this for at least 8 years or so, and we've been presenting to the industry both in New Zealand and abroad, and certainly in the last year and a half we've noticed a lot more interest in what we're doing. We get a lot more inquiries, a lot more people wanting to understand what's the difference between the different bioplastics that are available and what are the limitations and what are we doing.
Here at Scion, we're looking at taking bio-based materials, be they wood fibres, as in this case, or other residues from horticulture or agriculture, and incorporating them into either conventional plastics, like we can take wood fibre and put it in commercial plastics that are not bio-based, or we can take the wood fibre, in this case, and put it in a commercial bioplastic. A lot of our research here at Scion is based on radiata pine, because that is the highest commercial forestry wood in New Zealand. Here we have an example of the Mulford BioPeg. It's an erosion matting controlled peg that Scion developed to break down in the ground benignly, leaving no toxic traces to the soil around it. Traditionally, when these erosion control matting pegs, either plastic or steel, were left in the ground with the erosion control matting, you needed to know exactly where each peg was to retrieve it. Now, using a combination of commercial bioplastics and waste residues and wood residues, we were able to develop a peg that, if by chance it was left in the soil, it would not cause any harm to the environment. The technological breakthrough was, if you used a conventional bioplastics on the market, it would be too brittle to be hit with a hammer into the ground. Zespri approached us because sustainability is a very important part of their business model, and their current polystyrene spifes were taking up a large part of their carbon footprint, and so approached us to develop a bioplastic solution. So we took kiwi fruit and kiwi fruit residues from the value chain at Zespri and incorporated whole fruit or fruit byproducts into a plastic that could be moulded on the same equipment as the current commercial styrenic spife. Scion are positioning themselves to take any limitation of existing materials, existing bioplastics, and look at using waste residues, horticultural residues, or chemical modification even, to improve the mechanical properties or the physical properties or even the biodegradation properties of different materials.
This program was made with funding from New Zealand On Air.